Differential leveling is the process of measuring vertical distances from a known elevation point to determine elevation of unknown points. The most common methods to determine elevation are through the use of first, a compensator type, automatic engineering level, and level rods, and second, an electronic digital barcode leveling instrument with barcode rod. A thorough knowledge of leveling principles and proper application of methods and equipment will prevent costly delays and generate the needed results and accuracy.
Objectives. First is to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing a single setup. 2. To acquire the development skills of determining the elevation of a point from a benchmark of known elevation by establishing multiple setup using turning points. And third is to develop the skills in using leveling instruments.
Instruments and accessories: auto level, leveling, rod markers, plumb bob.
A. Single setup differential leveling. The instructor assigns the location of 2 points marked as A and B, which are intervisible with the instrument setup placed between the 2 points. Set up the instrument level on a suitable points, preferable about midpoint of the 2 designated station A and B by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of instrument man through tripod legs locks. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backside reading of point A where leveling rod is being held vertical with the aid of plumb bob. The reading must be done up to the accuracy of a millimeter or 1,000th of meter. Rotate the telescope after point B is in sight. The rodman transferred the leveling rod at station B and must behold it with plumb bob alongside to maintain the verticality of the rod. Take the Foresight reading of the leveling rod and again, the reading must be done up to the accuracy of a millimeter or 1,000th of meter. After recording the observed values, compute for the difference of the readings to determine the difference in elevation between benchmarks. Repeat procedures 1 to 8 for second and third trial. Tabulate the data in Table 4.1, Single Setup Differential Leveling.
Differential leveling with turning points. Step 1. The instructor assigns the location of another 2 points marked as A and B. Step 2. Set up the instrument level on the suitable points, preferable about midpoint of the 2 designated station A and B, by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of instrument man through tripod legs locks. Step 3. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backside reading of point A where the leveling rod is being held vertical with the aid of a plumb bob. Step 5. Rotate the telescope until the newly established point, designated as turning point, can be sighted. Ensure that the turning point should be almost equidistant. Form the instrument as the first benchmark from the instrument. Step 6. The rodman transfers the leveling rod at turning point and must hold it with plumb bob alongside to maintain vertically off the rod. Step 7. Take the Foresight reading of turning point where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or thousand of meter. Step 8. Transfer the instrument to another location along the route to BM2 where the first turning point is still visible in the telescope, and follow the same procedures as in 2 to 8 until you reach the second benchmark. Step 9. Tabulate the data in Table 4.2, Differential Leveling with Turning Points. Compute the height of instrument or HI and elevation. To get the HI, add the elevation and backside. To get the elevation, subtract the HI to the Foresight.